Hello, everyone, and welcome to day 10. And today we'll be talking about variant calling. And what do we mean by variant calling? You do a very deep search where you'll find where your isolate differs from the reference. In our previous day, we are able to align. What we've been able to do is successfully align it. But what does that alignment? What information does that alignment? What does it tell us? So, what we call variant coding is finding where your isolate, your sequence, your sample, how it differs from the reference. So, we call snips, it's called SNPs or SNPs, depending on how you want to be fancy with it. SNPs, SNPs, single nucleotide polymorphisms. So, and then indels, insertion deletions from your band files using GAT4K4 haplotype caller. So that's the haplotype caller. That's the tool to do the variant calling. So we call it variant calling. So that's what we want to do. And then likewise, understand the VCF format and apply add filter quality thresholds. And you have to run TB profiler to predict dog resistance from variant data. Now, and what does this mean? Especially the third part, there is a particular tool, platform, or that's called TB Profiler. So, and one of the ways you would know a variance or where drug resistant variants, especially when it comes to treatment of diseases, is when you run the alignment and you see there is a change. And when there is a change in something, there is likelihood that it's informing not just structural but functional differences or information. So that is why we have to do this and study. So GATK is Genome Analysis Toolkit. It was developed by a particular institute. Haplotype Caller is its variant calling engine. So this toolkit haplotype caller GAT4K4 haplotype caller. It is the most widely used variant caller in clinical and research genomics. It is used in 1,000 genomes projects, UK Biobank, and thousands of published studies. So that means what we are doing is something that has been tested times and time again. So there are several features: active region detection, local reassembly, pair HMM likelihood calculation, genotype assignment and scoring, and the likes. We are still, as it's customary, we are still going to come to this because this might be abstract to us right now. So GAT K4 is the gold standard for SNP and indel detection from short read sequencing. So you have to read that: short read sequencing, not long read. So now this variant calling, it comes out as a VCF file. Now here it says that not every variant in your VCF is real. Filtering is essential. That means all the steps that we are talking about from the beginning, if you skip one step, you will get a wrong result. If you do not skip one step but you did the step wrongly, you will get a wrong result at the end of the day. And it is very, very important that we take note of that. I told us a story about how when I was doing my master's, I discovered, hey, a new discovery. Yeah, I've gotten a new biotype from Africa, a biotype that is known in Asia. But unfortunately, it was a false flag. It was wrong. So, and there are several factors, just like I explained in the video. Now, this is how a VCF format looks like, and this is the description of each and every of the step. There are 8 parts that we should know: the position, the quality, the DP, the GT, the ref, the alter, the filter, the AF, and AD. We are still going to get to that, but here, the chromosome position. The chromosome position, or chromosome and base position of the variant, and then the ref identity, it's here. The reference is here. The alteration alternate base is here. We know that the alternate base of C is T, G is A, so there's no discussion about that. Then the Phred score quality is here. The filter Does it pass through the filter? Yes, pass or no. Yeah. And then the DP is depth, the depth of your sequence. Total read coverage at this position. Low depth is less than 10 and it's an unreliable call. For example, here there is no the depth of this one, this particular position is low, less than 10, so it's an unreliable call. So then we have AF, allele frequency, and then allele frequency is here 0.1.0 or what have you. And then we have the GT is the genotype, and here we have AD. If it is no, it is low insufficient coverage, and as you have it. So AD is allelic depth. So you can have this particular features while describing your samples. So now TB Profiler is a drug resistant prediction for whole genome sequencing from a VCF file to a clinical drug resistant report in minutes. So as you can see, you can interpret TB profiling output by the different colors that it brings out. So how TB profiling works: one, compares your BAM file and all this boring description. You can read that. It's not boring, don't mind me. You can read that and get more information about that. So where we are going with Galaxy is this. Okay, so the first tool that we are going to do is the GAT. Let me enlarge so that it can be clearer. So GAT 4K K4 profiler. So you can search. So you can see GAT 4K, calling germline, SNP, and the likes. So the next thing input is sorted index BAM, sorted indexed BAM. So now it's going to take us to the sorted index BAM file. Sorted. Let's see. So as you can see, this is the reference, and then this is the tool it wants to run against. So automatically it will pick it. So that's number 34, which is sorted. So which is the one that we want to check, and then leave everything as it is. And then yes, day 9, deployed, put it at 1. The reference is already done. Ploid is put it at 1. So and then let's see, let's play around with this. Nothing selected, nothing selected. So nothing selected. Let's leave it at DNA sequencing. So let's run tools. So we're waiting for it to run. Let's wait for it to run. So as you can see, we have this problem. It's not successful, which was the problem I was envisaging for since. So let's click on icon and see what the problem is. So you can see the problem is here and all the details that it entails, but we are not still. Let's click on the error itself. Where is the error? So dataset error report. So you can have the dataset error report here. Fatal error, blah 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 blah. So basically what I now did was that I copied all this error information. I copied everything. So I now brought it to ChatGPT, and I posted everything here. I just said, please help diagnose and fix this problem. Same problem. And it brought all this diagnostic reports. And when I said, oh, no, I'm looking for solution on Galaxy. So and it broke it down. So it says if you are running this in Galaxy, the error is almost always caused by BAM file lacking a valid read group with a sample name. So the problem is read group, sample name. The important clue is this. It tells us the important clue. Now, GAT read sample names from BAM files, not the file name. So, and that is where the problem is. It says in the Galaxy, click on the BAM data set. So let's click on the BAM data set. So the BAM data set is this one. Is this one that I showed you earlier on. Aha, this one here. So this is how it looks like. As you can see, ChatGPT said I should click on the BAM data set, click on the eye icon, search for @rg. I search for @rg, it's not there. What we have is PG. And here it says you should see something like this, @rg ID sample, and this is what it was referring to, @rg ID blah blah blah, the sample name, @id rg. So what we have is @pg, so which was the major problem. If there is @rg, then the application will fail exactly. If there is no rg or sm, what we have, we don't have even have sm, we only have sn, so which is a problem. So the Apple type caller will fail as exactly as shown. So what are the steps? Step 2, add root groups in Galaxy. Search Galaxy tools for PyCard or add replace group. Use this. The critical field is RGSM. It is recommending solution for me. Now, I want to emphasize this because sometimes when you have solutions, your solutions can even make it more confusing. You have to be calm in choosing the solution. Then check whether the BAM is empty, run. So there are different solutions to do. It says step 4, verify the reference genome. I know the reference genome doesn't have problem. Then the common Galaxy workflow mistake is this. Many users do FASTQ, BMAW, SORT-BAM, and that's exactly what we did. And it says that for GATK, it expects you to do all this, not 4 steps. It expects you to do 6 steps. So, and this is the fastest way to confirm. And it gave me all those things. And I said, after running samples, I told ChatGPT that I used this. It came from my own workflow. That is number 2. Which aligner did you use? I said I used BWAMEM. Number 2, whether the BAM came from your own workflow? Yes, it came from my own workflow. Number 3, the output of the BAM header around what is it? I said it only had the PG ID lines. So then it said you have found the problem. So if your BAM blah 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 blah, it's like this, it exactly states what the problem I had was. HDSQPGPG. As you can see here, HDSQPGPG. So it's diagnosed exactly what my problem was. But Gatsky needs something like this. So that means I have to change it. So, and it explained why BWA did not add it for me. Now, to fix it in Galaxy, which is recommended, add group list to existing blah 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 blah, and this and this and that. It gave me then some tools, then this. But it says for better long-term fix. So this is what you should do. For better long-term fix, this is what you should do. It says I should go back to BWAMEM step. And which step is that? It is this step. So what I'm going to do is I'm going to search for BWAMEM. So this one, BWAMEM. Okay, there are many ones here. Don't let me map with BWAMEM. So this one, I'm going to search for it, and then after that, many Galaxy wrappers have the option like this or this. So what we are going to do is specify read groups. So you are going to, same way we did initially, build with this, and then algorithm constructing What have you? Let BW decide best algorithm. Then single or paired. Then you select your R1 paired, and then R2 paired, trigonometric R1 paired, trigonometric R2 paired. Now it said set read groups information. So this is where it is telling us. It says set, or it said I should search for specified read groups or set read group information. So enable it and fill in all this information. So we are going to enable it. So come in. So you have to set read groups, SAM and BAM specification. There are different specification. SAM and BAM specification, that because that is what we want to work on. So it says read group identifier ID. ID is 1. Then the next one, SM sample 1. As you can see, sample 1. So just exactly how it is doing it. Library is PL is LB is library 1. You can see, just look, shine your eye very well. LB is library 1, and then PL is Illumina. As you can see, we have Illumina selected here. This is PL, and take note of the start, which is required. And then PU is unit 1. Unit 1. Where is PU? Where are you? PU, where are you? I have not seen you. PU is unit 1. So that means you are good to go. So after you do that, then every dance will work automatically. So the next thing you are going to do is to click on run. So while it is running, so you can read more. Verify before rerunning Apple type caller. So you can see you should now see all this information. So that is that. So now coming back to the slides that I was explaining earlier on. So this is the long-term fix that I was explaining. Go back to your menu, blah blah blah, specify, and then every dance to work automatically. So you should verify and you should see the line. So then you should run your analysis. So let's wait for it to finish running. So now it has finished running. Let's check. So click on the eye icon as well. Click on the raw. So you can see it has changed to RGID, then SN. So unlike SM that it was before. Now you now have to come back to the previous steps. You have to come back to the sorts, the SAM tools, the this, and then you continue your analysis. So let's see how it goes in the next video. I don't want this video to be too long.